All right. So we made a box out of a piece of paper. We cut the squares off the sides. We have a different size. So this one's 11 by 8.5. This one's going to be longer by 3 inches. So identify the degree and the leading term of the polynomial. How do you think you're going to be able to do that? It's in factored form. How do you unfactor? Let's think of a word that you learned a long time ago, like elementary school. Distribute. Okay. So distribute. You might want to do this in 2 steps. First, distribute the 14, and then the 2x, and then get that answer. And then you'll have 4 numbers, or 4 terms, excuse me. Do you want to multiply the x by 4 things or just 3? Yeah, so after you distribute the 14 and the 2, combine like terms and just distribute the x, and then answer the question, degree and leading term. Okay? We just talked about in the warm-up. Go for it. So after looking at what everybody got, here's what I saw. And this was good. Okay. You did combine like terms before, so 119, right? Because that's 14 times 8.5, and it's minus 45x. And then plus 4x squared. And then we have to take that whole thing and multiply it by x. So then that equals...
45 or 41?
It's 45 because it's 28 and 17. Okay. So I paste, I get rid of the x, and I just bump all these up by 1. Okay. As I went around, most people did a pretty good job. Pretty good job with this. Some of you missed a sign. Some of you missed an exponent. So just be a little bit more thorough. All right. So leading term is the one in the front, right? No. The leading term is the one with the highest degree. So what I'm going to do here is, to make things clear, is this in standard form? No. So I'm going to move it around, okay? So let's put the 4. You don't have to, because it doesn't say right in standard form, but I would recommend it because that prevents some of the errors. So 4x cubed would be my leading term. And then 119 goes on the end. Okay. So thank you. So leading term, I'm just going to put an arrow. Leading term. Clock off. Leading term. Caleb, what's my degree? Okay. Logan? Third degree. So remember, the degree is always equal to the highest exponent. So this is a 3rd degree polynomial. Let's talk about one more itty bitty thing here. Polynomial.
Was that a word or a...
I was just a made up word. I do that a lot. All right. Without graphing, what can you say about the horizontal and vertical intercepts of graph of V? So we did the horizontal yesterday. So think about the stuff that we did yesterday. Okay. I don't know. Maybe don't look at the equation with that's expanded. Maybe look at the factored one and see if you can come up with the horizontal intercepts. AKA, that's another way to say horizontal intercepts. Not the Y. X-intercepts. So then the vertical intercept is... Okay. So find the horizontal and vertical intercepts, aka X and Y. Without graphing. Okay, one more time. What do we do with the vectors? Set them to 0. Okay. So it's more complicated if you use the equation in expanded form. So one of the advantages to factored form is it allows you to find your horizontal, aka X-intercepts, excuse me, a little quicker. Okay. So let's not use red. I don't know why I had red. Okay. Horizontal. You say the most random stuff sometimes. It makes me hysterical. Okay. Horizontal. set
There's no clouds outside.
factors.
No clouds.
You know you can get tan without sun. It's called the UV rays. They
I know.
go right through those clouds. Set factors equal to 0. All right. So 14 minus 2x. What you got there, Mario? Find that one yet? 7. Okay. So we have x equals 7 is one of them. Okay. Let's see. Rudy, give me another one. Hey, Rudy. Look at this third factor. Oh, you're gonna go for the big guns. Okay, go ahead. 4.25. Okay. And the easiest one is the one you don't have to do anything with. Not 1. Because x by itself, there's no number. So really what are you doing? You're adding or subtracting on 0. So what do you add or subtract to 0 to get to 0? 0. So those are our 3 horizontal, vertical. In a function, how many vertical intercepts can you have? Can you have 3? Yeah? 7? How about 30,000? No! What's the test we use to test something's a function? It's called the vertical line test. How many points can it go through?
1.
So how many vertical intercepts can you have for a function? Hey, let's write that down just to be sure. Okay? So vertical is the Y-intercept. Notice, it is singular. You will never hear anybody talk about a function with more than one Y-intercept. And there's only one. I won't bore you with the whole Highlander thing. There can be only one. Anybody ever heard of Highlander? No. It was a movie back in the 80s. Made it a TV show. At 80s? That was so long. You mean the 1980s? In the 20th century? Wow.
I was talking about from grown-ups.
Yeah.
Was 17?
Yeah. All right. The vertical intercept is super simple. How do you find the vertical intercept? Set x equal to 0. Because if I'm on the y-axis, I ain't going left. I'm not going right. So let's see. If I put a 0 in here and a 0 in here, and most importantly, the 0 right here, what's 0 times anything?
0.
So my vertical intercept is y equals 0. Okay. Let's confirm we've done this correctly. How can we do this? Go to Desmos, put in the original factored form, and then the new one, and then we confirm our intercepts or we say they are. Hey, I just happen to have it right here. In the interest of time, I'm going to take a look here. All right. Boop. So there's my original. Here's going to be my new one. And I'm going to put it in. I'm going to be a rebel, not even put it in standard form. So what am I looking for? How do I know I did this correctly?
They should line up each other.
Blend. Goes right on top of each other. So it was black, and now it's going to be
Blue. Oh.
Huh, I made a mistake. What happened?
You made a mistake.
I did it again, didn't I?
It's supposed to be.
Nah, up here, this is x, and over here it's x squared. Now it's blue. Okay, so let's confirm what we got. Here we go. 0, 0. So that's both a horizontal and vertical. You mean I can have 2 at one time? Frequently, if it passes through the origin, the origin is both a horizontal and vertical asymptote. I've got 4.25 comma 0, and there's my 7. One of these is an imposter. Dun, dun, dun. Remember, this is a box, right? So if I have a box and it's 8.5, I can actually use another piece of paper because I want to completely fold it. But I don't want to fold my lesson plan.
That's fine.
Over here, my piece of paper that's 8.5. All right. So as I said, we have an open box. Yes. With our open box, the x-intercepts is where we fold up. So if I don't fold up at all, I still have a piece of paper. Is that a box?
No.
Nope, that's why my volume is 0. Okay? So it doesn't make sense, but at least we understand, like, it's not a box. This one, not a box either, because I'm taking this edge here and folding it in half. Because 8 divided by 2 is 4.25. Is that a box?
No.
8 divided by 2 is 4.2.
No, it's not a box. That's just a piece of paper folded in two. So my box with the most volume will be this one. So if I cut off 1.7 inches, not off of this one, but we have to vision this. That's to be 14 inches long. So let's see. My domain is going to go from 0 to 4.25. Well, what's this then? It's nonsense, okay? Because once I folded this up at 4.25, this is my domain. So remember, another thing that kind of tells us what happens underneath here is, can you have negative volumes of a box? No. So that's why the 7 is a nonsensical answer. So even though it works on the graph, it doesn't make any sense for the box.
It's my heart-shaped box.
It's your heart-shaped box. That's lovely. All right. So we're not going to do all of these. In fact, we're only going to do one of these. Okay? So you're going to split the work. We're only looking at C and D. Okay? So work with a partner. So Artemis, go find somebody. Okay? People are in trios. Okay? One of you is going to do C, and one of you is going to do D. And then you get to choose. You get to pick one. You're going to pick a polynomial. Okay? And you're going to pick another polynomial. So just like C or D, one with 2 terms and one with 3 terms. I had a few people in period 2 that had some issues. Okay? You can do a trio, Ahmad. You're fine. Okay. All right. So 2 binomial times trinomial. One of you do C, one of you do D, and then you get to make one up and hand it to the other. So you're only doing 2 problems, either C or D, and the problem your partner makes. Go for it. Here, we're going to spot the differences between these 2 functions. So you don't have to type this in Desmos, but if you want a record of it, I would put it in Desmos and link it, and I will do that before we're done. So I just happen to have these graphed as well. So I'm going to go over here, turn off my box, turn on my problem number. So, whoopsies. Oh, didn't want to see that yet. Okay. So, here are the 2 graphs. Notice, it asked you, hey, let's put them between -10 and 10, and this is close enough. -10 to 10 and -100 to 100. So, after they're graphed, you're asked to do this. Describe how the 2 graphs are same and how they're different. So make 2 text boxes, call one same and one different, and then put in the sameness, the similarities, same, don't need to capitalize, same, I just love typing with one hand, and differente. All right. So looking at the graphs, so like I said, you don't have to graph them. Ooh, I don't want that one. If you just want to use mine, but the only issue with mine is you're not going to be able to touch the screen. I mean, you can come up here and touch the screen if you really want to, but so what's the same and what's different about these 2 graphs? And then after that, what degree do these polynomials have? And rewrite them in standard form to check to see if you are correct.
Wait, Max supposed to do this still?
Okay, so let's just like normal classes, raise your hand. Yes, Mr.
They have
Same or different?
same.
Okay.
X-intercepts.
Same X-intercepts. Okay. Anybody else? Rita, something different. Same.
They have the same
And behavior. We're starting on going from negative infinity on the left to positive infinity on the right. Proper vocabulary terms too. Excellent. Okay. And behavior. What else is the same? Geraldine, what else is the same? What were we talking about? Domain and range. Okay. First class that talked about that one. The other classes did not mention at all. Anything else that's the same? Anything else? Okay. That's enough. Oh, you were talking about it. What did you talk about? They both have a what?
Maximum.
Yeah, they both have one maximum and one minimum, relative. Okay? So one relative max, one relative min. Hold on to that thought. Okay? So I'm not saying what they were, I'm just saying they have one. So max and min. All right. So now the differences. Hey Noah, what's one of the differences?
They have different maximum and relative.
Okay. So max and mins are different. And min. So if I take a look at my graph, so this one's got a relative max at 48.13, and this one's got a relative max at 24. They look really kind of like they're connected somehow, huh?
Yeah, they're wise.
Okay.
Not wise.
So it looks like the purple one is about what of the green one? Half. Hey, look at the coefficient in front of all the parentheses. It's half. So the number in front, that doesn't affect the horizontal at all. It only affects the vertical. So that's why we have different relative max and mins. It's actually, in this case, it's not stretching it, it's compressing by a factor of a half. Okay? All right, what else is different besides max and mins? I heard somebody talk about it. The Y-intercepts. Okay? On the X-intercepts, they matched up, but the Y-intercept, let's undo all these. Okay? I had 21 and 42. Again, the purple is half the green. Okay. So Y-intercepts were different. Anybody else have anything else that was different? The colors were different. Thank you, Caleb. I appreciate that.
That wasn't necessary.
Not sure if they have a mathematical significance, but yes, we have different colors. All right, so let's add one more color. Okay, so we're going to come back to 2, because in the interest of time, I don't think we're going to get to 2 at all. So on number 3, ready? I'm adding this one, and I'm going to get rid of this one. So this time, instead of getting compressed, getting stretched. So what's happened to the graph? It's stretched by a factor of 3. So let's just type that in. Okay, f of x is stretched, not treached. These are not treacherous problems. They are quite benign. Stretched. It is. Yeah, because take a look. What's in front of the x minus 2? It's now 3x minus 6. Not x stretched. I'm just having issues. Okay? By a factor of 3. Most of the time, I would make you do all the work, but we're getting a little short on time. All right. And we're not going to worry about the standard form. Okay. We've done a lot of that already. So last thing we're going to do is you've got 2 graphs, 2 different vertical intercepts with the same horizontal intercepts. Find the value of k. In other words, my original graph was green. How do I know it's green? Because f goes with the green. And my new graph is blue with g. So how do you get from the green graph to the blue graph? Write it before you say it. Matthew had an idea. What did you notice, Matthew? From green to blue, is it getting bigger or smaller? Smaller. Nice save. Okay. So if it's getting smaller, should k be bigger or smaller than 1? Smaller. So find the fraction that k is equal to make this graph work out. In other words, how do I get from green to blue? So how do I get from, I'm going to make him laugh even more. How do you get from to He started it. Okay. So let's try this again. If you weren't sure, where do you think I should focus my attention on? The bumps that aren't like really easy to find, or the parts of the bumps that are really easy to find?
Really?
Yeah, in this case, our relative mins right here at 0, -1, and 0, -5. So to get from -5 to -1, I multiply by,
5.
nope,
Right.
rice, not rice.
2 hours.
Okay, so at this point, look at the summary. And the only thing that you have to get done after you're taking a look at the summary, what have we been doing every day after the lesson? The cool down. Cool down you should turn in before you leave. There's only 2 parts to the question. And the practice needs to be turned in by the end of class tomorrow. We are going to start a new lesson tomorrow, so you probably want to start looking at some other stuff. This is 2.26. We've done 2.24. Some of you haven't turned that one in. 2.25. Some of you haven't turned that one in. So it's kind of snowballing with you right now. You need to get the cool downs done before you leave, and you need to start on the practices. Okay? So go ahead and get to work on that. And we are officially done for lecturing. You get the cool down and start as much as you can get done on the practice as possible.
So we're supposed to do lesson 6 summary?
Yep.